Hello again there, my physical science students. What we're going to attempt to do here is work through a virtual circuits lab. So this is a lab you would have done if we were still in person in class. So I'm going to build the circuits so you can see them in the video here, and then I will have a few questions for you to respond to in a Google Doc in Classroom. So we've got a few supplies here. I know it's a little dark here. I don't have the big light on, but I think it'll work out better for seeing what happens with the circuits. We've got our battery or our voltage source. We've got a couple lantern batteries. We won't necessarily use all these supplies. I just kind of grabbed a handful of each of the things. We've got some small light bulbs. You can see you've got the light bulb that screws down into this base. And then you've got metal contacts on either side that you can connect to for the circuit. We've got just some metal paper clips that are stretched out here. These will act as branching points for us, allowing us to connect different loops together. And then we've got our wires. We've got some black wires, and we've got some red wires. So to start off, we want a voltage source. I'm going to do my best to fit everything in here. I'm not sure how well it's going to work out, but we'll try it out. And we're going to start off by building just a simple circuit with one light bulb. So for that, we've got a wire that we're going to connect to our positive terminal. We're going to connect that to a light bulb, and then connect from the other side of that light bulb back to our battery. As long as everything's working here, you can see the light bulb lights up. It's pretty bright. Now what we're going to do is we're going to add a second light bulb to this circuit. So I need another wire, and we're going to do this in series. So it's just going to come one right after the other. I'm going to unhook from that so I can connect to here. And since we're in series, we want the current to have to flow through both of these. So we're just going to go from the voltage source to this light bulb, then to this one, and then back to the voltage source. Two more light bulbs there. Not sure how well you can see it on the video with the document camera here, but they are noticeably dimmer than the one light bulb was. We're going to continue this on then and add a third light bulb in series. So again, one coming right after the other. Now they're even dimmer. The final thing we want to do is we want to create a short circuit. Or sorry, I mean an open circuit here. So an open circuit would be where you have a break in the circuit and what happens then. And we've talked about this, but now you'll be able to see. If we create a break somewhere, so let's say we just break this from one side, you can see that no current can flow. You've got it going into one light bulb, second light bulb to here, but now there's no way for it to get from here back to the voltage source. If we touch this again, you can see immediately as soon as I make that connection, they light up. If I take it off, it goes dim again, or goes out again. So that's one light bulb for a simple circuit, 2 and 3 light bulbs in series, and then showing what happens with a series circuit when it's an open circuit, when you've got that break in the circuit. Next, I want to look at a parallel circuit. So we're going to keep 2 of our light bulbs. And the way we're going to do the branching for parallel is we're going to connect the wire from the voltage source to this paper clip. And what that'll allow me to do is connect multiple wires to this. And so you can see now I've got a path for the current to flow on either one. And so we'll create 2 loops for our current to flow through. Now I'm going to do the same thing from the positive terminal of the battery. Again, connecting from the battery, from the voltage source to the paperclip, which is just allowing us to create this break in the circuit. And so I've got now are 2 different pathways that my current can flow through. I can come to this side and to this light bulb, and then back to the battery. Or I can come through this outer pathway to the light bulb and back to the battery. So you can see both light bulbs are lit up, and in fact they look brightness wise like when I had just the one light bulb. Now what I want to try and do here, and it's going to get a little cramped, but I think we can make it work, is to add a 3rd light bulb also in parallel. So you can see I'm going to add a 3rd wire coming off of my paper clip. And I'm going to do that for both sides. So you can see here as well. Oh, maybe if I get it in close enough. I have 3 wires coming off of my paper clip for the negative terminal as well. Grab a 3rd light bulb and connect on both sides of that light bulb. You'll notice when I make this connection, there's no change in brightness with the other 2. All 3 light bulbs have that same brightness as when I had just one light bulb. Now I can create an open circuit here by making a disconnection just like I did in the first circuit, or with the series circuit. And so if I disconnect one of these, you'll notice that light bulb goes out, is no longer lit, but the other 2 remain lit. Why can that happen? That happens because our current still has a pathway, 2 pathways actually, to flow through because they're in different branches here. And so if that break or that open circuit occurs in just one of those branches, the others can remain lit because there's still pathways for the current to flow through. The final thing I want to show you with this is what happens if you have a short circuit. A short circuit is where you've got your wires connected up, your circuit connected up, but then you have a basically direct connection with your connecting material from the positive to the negative terminal on your voltage source. And you'll notice if I do that, the other 2 don't go out quite, but they very nearly go out. You can see there's just barely anything lit. Why is that? It's because when I have the current flowing, it wants to take the path of least resistance. Well, if I've got a light bulb here, that's acting as a resistor, providing resistance to it. That's what allows us to get the light from it. It's converting that electrical energy into radiant energy or light for us to see. But if we create this connection where it's just conducting wire, which has very low resistance, the current wants to flow through that. So most of it flows through here, very little through the light bulbs, and so you get that effect where the other bulbs dim almost to nothing. I'll go ahead and disconnect this here because we're done with that. That's all I have for this virtual lab for you. Make sure you answer those questions in the Google Doc, and that's what we'll have for today. Have a good day, and we'll see you again tomorrow.